All right, question number 8. This one we have 8 parts. Okay, it says a researcher wanted to determine the number of televisions in a household. He conducts a survey of 40 randomly selected households and obtains the data in the accompanying table. We're going to complete parts A through H. And so first we want to know, are the data discrete or continuous? So I'm going to look at the data, and each of these numbers is a whole number. So there are no decimals, no fractional parts. So the number of TVs in your house could not be like 1.5. What would that mean to have a half a TV? Now we can talk about 1.5 bathrooms, so it's not like a full bathroom. You don't have a shower in there. But as far as the number of TVs, we're going to have a whole number, 0, 1, 2, or 3. So this would fall into the realm of discrete data, whole countable numbers. So the data are discrete because they can take on any real value. Real value would not be the explanation there. Discrete because they can only have whole number values. That's what we're looking for. And then the other two options say continuous, which we should only be looking at A or B because it's discrete. All right, so now we're going to construct a frequency distribution. So you can do this with a calculator or with Excel. I'm going to use Excel. I think it's going to be a little bit faster. So I'm going to tell it to copy this in Excel. So it's done that. I'm going to open this up and see all my data is here. So what I'm going to do is I'm going to click this column. I'm going to go to data. I'm going to tell it to sort and just do A through Z. It's going to do smallest to largest, as you see here. And so here, every number is now grouped with the number of repetitions. So I can count the frequency now. So the frequency for the number of households that have 0 televisions, 1, 2. There's 2 zeros. Come here and put a 2. All right, so now I'm going to go back and I'm going to count all the ones. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. All right, so I'm going to count the number of 2s starting on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 2s. Count the number of 3s. So starting here is 1, 2, 3, 4, 5, 6, 7. 7 with 3. Number of 4s is 1, 2, 3. And then the number of 5s, 1. So what you should do as an intermediate check, I would just add these numbers up and make sure we get a total of 40. It said 40. So I'm going to add these numbers. 2 plus 12 plus 15 plus 7 plus 3 plus 1. That gives us 40. So good intermediate check, and then we'll get a confirmation there. So we're going to do a relative frequency. So I'm going to use these numbers, divide them by 40. I'm going to use the calculator to just divide each of those by 40. I'm going to clear out the information we had here. Clear. And then I'm going to input these numbers. 2, 12, 15, 7, 3, and 1. Of course, you can do this with the basic calculator, but it'll just take a little bit more time because you got to divide them all one at a time. Here, I like this method. It's going to do them all at once. So I'm going to tell it L1, take that list, divide those numbers by 40, and we get these numbers. So they want us to type integers or decimals, do not round. So I'm going to type those exact decimals: 0.05, 0.3, 0.375, 0.175, 0.075, 0.025. All right, what percentage of households in the survey have 3 televisions? So 3 was 0.175. You move the decimal 2 times to the right, so we're going to get 17.5. All right. E, what percentage of households in the survey have 4 or more televisions? So 4 or more would take this category and the next. So if I add up the 75 and the 25, that will give me 1. So that's like 0.1. and you move the decimal over, so that's going to be 10%. So let me just show that calculation. 0.075 plus 0.025. It's going to give me 0.1. Move the decimal 2 times to the right, or you can just multiply by 100. That's the same as moving it 2 times to the right. You get 10. So we're going to get 10%. F, we want to construct a frequency histogram of the data. So the data, go back to stat and look at this. So these were the totals: 2, 12, 15, 7, 3, 1. So it starts low, it goes up, and then it starts dropping back down. So this one looks like it matches that pattern, and that is the one that looks like it matches the closest. You can look, this one looks like a height of, what is he counting by? 1, 2, 3, 4, 5, 6, 7, 8. So goes up to 16. It looks like they're each counting by 2, so that would be 2, and that's about half. So that looks correct for the first one, and this matches the frequency. So A looks like the best match. All right, the next one, we want to construct a relative frequency histogram. It's going to be the same. It's just going to be using these as my heights, but the graph will be pretty much identical to the previous one. So B is going to be the best match there. And then H, we want to describe the shape of the distribution. So we talked about shapes in the previous section. This almost looks more normal, almost bell curve. This would be skewed to the right. This one would be skewed to the left, and we don't have a uniform one. So based on that shape, I would want to say that it is uniform. Okay, you might be able to give a skew to the right argument, but let's see what they believe. Okay, so they think skew to the right. Again, you can see the difference. This one is definitely like a skew to the right, in my opinion. This one is a little, I guess, like I said, you can make the argument for skew to the right, but in my opinion, it looks more bell-shaped. Okay, so let me, while we're here, before I stop this one, these are the rough shapes. So this is a skew to the right, the tail is on the right. All right, then you have one that is skewed to the left. It's pretty much the opposite. The tail is on the left side. Bell shape, just think about like the Taco Bell symbol. It kind of goes flat, and it kind of like, so you got like a hump in the middle. So that's what, in my mind, I'm used to seeing that. So that's the hump in the middle. And then you have the uniform, which is just like you had a bunch of bars that were like even height all the way across, roughly about the same. So in my opinion, it looked closer to this. Again, you could have made the argument for skewed to the right. So that'll do for number 8.